Your AI system can sound confident and still be wrong. That is the trap. A model can produce clean sentences, polished summaries, neat classifications, and very plausible plans while quietly failing the job you actually built it to do. So the question is not, does this AI look impressive? The question is, how do we know it works when nobody's watching? Most AI teams start with vibes. They run a few prompts. They like the outputs. They show someone a demo. The demo feels good, so the system ships. That is not engineering. That is sampling from your own optimism. The problem is simple. AI systems fail in soft ways. They drift. They miss context. They follow the wrong instruction. They produce an answer that feels reasonable but violates the goal. If your only evaluation method is, I read it and it looked fine, you do not have a measurement system. You have a mood. An AI evaluation is not just a test of the model, it is a test of the whole system. The prompt, the retrieval layer, the tools, the routing, the memory, the schema, the fallback behavior, the guardrails, the user experience around the answer. A weak system can hide behind a strong model. A strong system can make a smaller model useful by constraining the problem properly. So before you evaluate anything, define the unit under test. Are you testing the raw model response, the full workflow, a single agent step, a production task from input to final output? Until that boundary is clear, your evaluation results will be noise. The first pillar is task clarity. You cannot evaluate good AI. You can only evaluate performance against a specific job. For example, extract the contract renewal date, classify the support ticket, draft a reply using only approved facts, detect whether an answer contains unsupported claims. Choose the next workflow step. Each job needs success criteria, not adjectives, not high quality, not better. You need observable rules. Was the answer grounded in the supplied context? Did it include the required fields? Did it refuse when the input was insufficient? Did it preserve the user's intent? Did it avoid actions outside its authority? Evaluation starts when the target stops being vague. The second pillar is the test set. This is where most teams underinvest. They keep testing the same easy examples, then wonder why production feels different. Your test set should contain real shapes of work, clean examples, messy examples, edge cases, ambiguous requests, missing context, conflicting instructions, inputs that should trigger refusal, inputs that should trigger escalation. You do not need a massive benchmark to begin. You need a representative one. Start with examples that match the tasks users actually send. Then add failures you have already seen. Then add adversarial cases where the system is likely to overreach. A good evaluation set is not a trophy. It is a pressure chamber. The third pillar is separating the signals. Do not collapse everything into one vague score. That hides the failure mode. Remarkun, an AI answer can be fluent but incorrect, correct but incomplete, complete but unsafe, safe but useless, useful but too slow. So evaluate dimensions separately. Accuracy, grounding, completeness. Format compliance, tone, safety, latency, cost, tool use, escalation behavior. The point is not to create a complicated dashboard for decoration. The point is diagnosis. If accuracy improves but latency becomes unacceptable, you need to know. If format compliance is perfect but grounding collapses, you need to know. One score tells you whether to feel good. Multiple signals tell you what to fix. The fourth pillar is judging. Some outputs are easy to check with code. A JSON schema either validates or it does not. A field is present or it is missing. A classification matches the label or it does not. But many AI tasks need judgment. Was the answer faithful? Did it answer the real question? Did it use the right source? Did it hallucinate? Did it follow the policy? You can use human review. You can use automated judging. Often you need both. But treat judges as systems too. Give them rubrics. Give them examples. Keep the scoring narrow. Make the judge explain the specific failure, not just assign a grade. And never let an AI judge become an unquestioned authority. It is a measurement instrument. Measurement instruments need calibration. The fifth pillar is workflow evaluation. This matters because real AI products are rarely one prompt. They are sequences. The system reads context, chooses a route, calls a tool, interprets the result, writes a response, maybe asks a follow-up, maybe escalates. Each step can be correct in isolation and still fail as a workflow. The retrieval can bring the wrong context. The agent can call the wrong tool. The final answer can ignore the evidence. The system can succeed once, then fail on the next turn because state was handled poorly. So test full journeys. Give the system realistic inputs and inspect the path it takes. Did it gather enough information before acting? Did it stop when confidence was low? Did it preserve constraints across steps? That is where production reliability lives. The sixth pillar is closing the loop. Evaluation is not a one-time gate before launch. It is how the system improves after launch. Every production failure should become a future test. Every strange user input should sharpen the test set. Every manual correction should teach you where the system is weak. This is the leverage point. Most teams treat failures as isolated incidents. Strong teams convert failures into durable evaluation cases. That means your test set becomes smarter over time. Your prompts become less fragile. Your workflows become more constrained. Your product becomes easier to trust because it carries memory from real failure. Not emotional memory, engineering memory. When evaluations are weak, AI development becomes argument. One person says the output is good. Another person says it feels off. Someone changes the prompt. Something else breaks. When evaluations are strong, development becomes engineering. You can compare versions. You can see regressions. You can decide whether a change made the system better, worse, or just different. You stop debating taste and start inspecting behavior. This is how you build AI systems that survive contact with real users. Not because the model is magic, because the system has boundaries, tests, measurements, and feedback loops. That is the difference between a demo and infrastructure. So tie it back to the opening. If your AI system only looks smart, you are guessing. If it has evaluations, you are engineering. The takeaway is simple. Define the job, build the test set, separate the signals, judge carefully, test the workflow, and turn failures into future checks. That is how you know whether the system actually works. Subscribe to Mind Games Labs for sharp breakdowns on data, AI, automation, and digital leverage. And if you want the operating philosophy behind the work, go to estd.com.au.